Hello, it's Brian from Robotacy again, and today we're going to continue on with our big Arduino project, as I called it. Recall that I'm going to be converting, you can probably see it a little bit here, this classic Batmobile into a fully functional autonomous campus navigator with GPS, and I'll have an RC override control on it, and hopefully even a Teddy Ruxpin that's going to be telling, getting upset as it gets lost or whatever else. So let's get started with explaining a few things. I'm going to zoom in on this because this is kind of important. Alright, so now we can kind of see this. What I've got is, I've ordered a new one, but for the moment we're going to be using this antique. It's an old Airtronics. It must be 15-20 years old, I suspect. It's a 6-channel, and I have the receiver here. Okay, now there's a couple things. Airtronics back in the day used to have a very funny format. Their servos and controllers and such were wired differently than what they are today for a standard. Typically now, when you get a servo, for example, or anything, it's going to be, well, you can see it here. It's going to be the light color, the signal, then the power, then the ground. Airtronics decided to throw a loop into it, and they had signal, then ground, then power. Okay. So if you happen to buy one of these antique old Airtronics, please don't plug it in directly. You might damage something. What I've done is I've rearranged the wires at this end. Okay? So I've pulled out the ground wire and the red wire, and I've moved the ground wire toward the center. Okay? I left the signal where it was. And I've completely actually left out the red wire. Out of the way. Reason is that my board here is going to be hooked up to a power supply running 7.2 volts, and I'm going to actually have this whole side of the board supplied with 7.2 volts, and I don't want to be feeding 7.2 volts into my Airtronics. Okay, so I've just left all the powers out. Even when I get my new receiver, which will be of the same format that we all know and love, I'm going to pull these red wires out. I don't want to be back feeding power. It's a bad idea. And the other thing I've done here is these two wires, these smaller ones, the red one and the dark blue one, they actually supply the Airtronics with a regulated 5-volt supply, which is currently coming from its tethered USB port. But when this is unplugged and running off batteries, there is a 5-volt regulator right here that will be able to supply the Airtronics or my receiver with 5 volts. You can see this is a 6-channel receiver. I have channel 0 hooked up to pin 12. I have channel 1 hooked up to pin 11, on and on down the line. At the moment, I don't have anything plugged into channel 5, the 6th channel. And the reason being is eventually, or shortly actually, I'm going to be trying out one of these things. This is an RC speed controller, and it's really nice. It has only one control wire. It replaces a servo. It understands, inside here is the logic, it understands the pulse width. If it gets a 1.5 millisecond pulse, it simply doesn't supply any power to the motor. And if it gets closer to a 2 millisecond, it gives a full power in one direction, and if it's closer to 1 millisecond, it gives it full power in the other direction. So this is designed for RC cars. Don't be fooled if you want to buy one of these. They make them for airplanes as well, and of course propellers only need to go one direction. So if you see one of those, and it seems unusually cheap, speed controller, it's probably for an airplane prop and it just goes one way. That would be a bad idea for your vehicle. Other than that, these two wires are ultimately going to hook up to the motor. These wire hooks up to the battery supply. There's the switch to turn this thing on and off, and like I said, one signal. So we'll be trying that out here in a little bit. I'm also going to try these things. These are nice. They're remarkably affordable. This will hold 2 DC motors. Oh, by the way, I don't know if I said it. This goes up. You can buy these things in huge amperage. I think this is like a 20 amp. This is only a 2 amp per motor. Nice thing about it though is it's very affordable. You can get these for like less than $10. The downside is you're going to have to actually, or we're going to have to actually teach it how to behave. It takes a minimum of 4 wires to run 2 motors, and preferably 6 to change speed. You can pulse the ends. I don't believe that's recommended. Usually you pulse the enable, so you turn it on and off to give it variable speed. But we're going to play with this one too here shortly. Going back, let's zoom back out a little bit. You can see that I have these ESRA arms, which are hooked up to 4 servos, and those 4 servos are hooked up here to pins 0, 1, 2, and 3. And ultimately I'll use my speed controller on pin 4, and of course I got a battery supply here. So let's take a look at code. So my code starts off with of course, an include the servo library. It makes life so much easier. And then I created these variables, these 6 variables, to be able to hold the pulse information, the number, the value that is going to be streaming in from my receiver. And I created here a total of 5 objects. 4 of them I've labeled servos 0 through 3, which correspond to the 4 servos that I have on the arm. And I've actually labeled one, even though I said servo here. I'm going to be calling upon the servo object to make a device that can handle a 1 to 2 millisecond pulse. I've actually labeled it DC motor because that's what I'm going to hook this up to. Then what I did is I had to set the direction of the pins. Remember, I have my receiver here, this thing, connected to pins 12 through 7, and I've set all 12 through 7 to input. The next thing I have to do is I have to attach these servos onto the board, and I do that with this simple command here. Remember, this is not really a servo. It's going to be my RC motor speed controller, but it behaves like a servo. So I've attached it here. And I've turned on the serial so we can see what's happening when we need to. I'm going to jump past these subroutines and let's go right to the code. Okay, here's the main loop. It's really simple. Not the most efficient. I'll talk about that in a moment. So I have my variables that are collecting the input signal, and all I've done is said, hey, let's do a pulse in. Let's look at the pin. Let's look at the high signal. Let's set a timeout, and let's collect that and throw it into that variable, and then let's jump to the next one, jump to the next one, jump to the next one, each one checking the width of the pulse of these pins, looking for the high signal and making sure that I don't just sit there and get hung up on it. Let's time it out. So let's not go no further than 25,000. And now in this case, I've jumped to the print values, and I've remmed out driving the servo. So print values jumps up to here, and I've taken and created this little subroutine that, serial print. It gives me this text so it's easy to read, and then attaches the variable, the value of the variable right after it, and then it gives me a new line, okay, the ln. So that way it'll be easy to read. I'm going to get a single line, the channel value channel 0 is equal to, then the actual value, then I get a new line. And it scrolls on down until we get down to the very last variable, being displayed. And then to make sure we can read it, I've put this delay. So let's load this up and see what we get. Okay, grab this, turn it on, and let's open up a window. Okay. So let's see if we can just look at channel, once it stabilizes here. Let's just look at channel 0. So I'm going to move this stick. And, oh, there it goes. Sorry, it's going the wrong direction. So if I move this stick over here, which one is this moving? Yes, okay. Okay, sorry about that. Actually, I had my antenna up. Alright, see channel 0? Okay, if I move the stick, the value goes bigger. If I pull the stick down, the value gets smaller. If you look at channel 1, I can lower that number, and I can raise that number. Alright, and it works for all of them. Okay, so I can now move to channel 3, and I'm going to bring it back up. Alright, and there you go. So that seems to work fine. Now let's try it with the actual motor control. I'm going to go ahead and close this out, and I'm going to rim this out, and I'm going to do that, and I'm going to load it up. And let's turn on some power, like so. And like that. Well, a little messy, but it worked. Okay. And let's see what happens. Okay, so you can see that I can control the 4 individuals. Now see how choppy that is? One of the things I want to do is we're going to be writing some code that'll be looking just for changes, so we can smooth that out. I can probably smooth it out a couple other ways. We need to get rid of all unnecessary material here. But it clearly works. In fact, it would probably be fine enough for my project, because ultimately this little jerkiness, it may not give me the exact precision, but it seems to be working just fine. And for steering something like that large vehicle, I think this is okay. But still, I'd certainly like to have it a little bit smoother. Alright, so let's call that one a success for the first run, and we'll move on to the next part of the project. I'll see you soon.